G'day, I'm Chris. I've helped hundreds of beginners level up fast in SolidWorks, and it always starts with nailing the sketch tools. These are the essentials I teach first and rely on every day in my own work. In this video, we'll dive into how SolidWorks handles sketch constraints. You'll learn what it means for a sketch to be fully defined, how to add sketch relations and dimensions, and how to spot and fix sketch errors. This is one of the most important videos in the series, so let's get into it. These lessons you're about to see are taken from my full SolidWorks for Designers course on Udemy, where I go deeper into the tools and provide project files to follow along. If you want to learn faster with additional content, practice files, and support, check out the full Udemy course linked below. So, Fully Defined, the name of my YouTube channel, Fully Defined-Design, free content, or for all different levels of SolidWorks users. So check that out. That's one of a few plugins that I'll place throughout this course. Now, while editing the sketch, it's when editing the sketch or in an assembly where you can see the note fully defined, you will also see underdefined and overdefined. And what that refers to is what kind of control you have on your geometry. So the example here is that every blue line you see is underdefined. What that means is there's no dimension or relation added to it that controls its position in space. This is a fundamental of design and CAD software. Different CAD softwares work in different ways. SolidWorks is parametric. Now, what does parametric mean? Parametric solid modeling is a CAD technique whereby 3D shapes are generated using computer algorithms with set rules. Users can define the parameters of their designs and so quickly and easily create 3D models. In simple terms, parametric modeling is one where you create geometry and then you constrain the geometry with dimensions or relations so that you can control the exact size and shape that that geometry is. There are other types of modeling called NURBS, for instance. There's other descriptions where you can create free-form shapes, very organic, curved, smooth, flowing. But if you tried to manipulate those with a very small amount of detail or control, you wouldn't be able to. You'd be limited in the ways in which you could modify it. What I've always loved about SolidWorks is if I have my design intent, I know what I'm trying to achieve. I know with the experience that I've got, I know the tools that I need to achieve that shape and that form. I can then create the geometry, create the sketches, create the 3D models and bodies. I can create all the detail I need to make something realistic, and I can get it to the exact size and spec that I need to within 0.1 of a millimeter or whatever manufacturing tolerance is available to me. It's no different with the very simple fundamental level here, where we add simple dimensions and relations to control our geometry. In this lecture, we're going to talk about relations, we're going to talk a bit about design intent, and we're going to talk about dimensions. And then we're going to go through and dimension this part to get it fully defined. Now, already in the sketches we've talked about relations, some horizontal, vertical, parallel. Let's go more into that detail now. If you cannot see the relations on your sketches, I want you to check a few things. First, I want you to check two things. First, that you've actually got some sketch geometry and it's editable, right? You can see the sketch relations on my screen, and I'm going to hide the front plane. The sketch relations are all these green dots. Now, the color of the dots might be different in different versions of SolidWorks software, but they are small green squares. If you're not in and out at sketch mode, all right, you won't be able to see them. Excuse me while I just hide my planes. Okay, so I'm out of the sketch. I can't see any of the relations. And the reason for that is if you had every relation viewing from an entire model, it just destroys the performance of the software. So sketch relations are contained to the actual sketch that they're in. You need to be editing the sketch to be able to see them. The other reason that you may not see them is that if, let's say, you've drawn a line like this, and this line has no relationship to the origin, it's not horizontal or vertical or parallel with something else, there's no relations added to that line currently. So it is possible that you've created a bunch of geometry with no relations. It's unlikely, but it is possible. And so before you worry about not being able to see them, just create a bunch of sketches and make sure you're in an edit sketch mode. Now let's talk about the different relation types. The very basic ones are vertical, horizontal. We've got another one here, which is parallel. And then we have coincident. We have midpoint. We have, which we'll see here in a second. We have tangent. We have concentric. And what others are there? Let's have a look. I'm going to select a line. Oh, and fix. We will talk about fix. Fix is not good. We'll talk about that soon. So those are the majority of our relations. There are also relations that are related to dimensioning. One of those, let me show you another example. I can make these two lines equal. So that means they are equal in length. If these two are horizontal at this point here and this line happen to be fixed, I grab one line and drag, the other one's going to match it. Which reminds me, we can also have a mirrored relation. This is a mirror, which means that this circle on the right is matching this circle on the left is matching the one on the right. You can also do, and then there are more advanced relations as you get into doing things like splines and more arcs and more organic type geometry. The CSWA exam outline does not actually mention which specific relations are required to be known. However, from some of the practice exams, we can see that it's really just the relations we've been over already here. Mirror, tangent, vertical, horizontal, angle, perpendicular, parallel, the standard sort of ones. Okay. So let's learn a bit more about how to add and remove relations. So you might create a line like this, and you want to make this line horizontal or vertical. You can select the line, and then on the left-hand side of the screen, you can see this box here, add relations. Now, this line is nearly vertical already. So SolidWorks thinks that maybe you mean to make this a vertical line, and it bolds the text for the vertical relation here. And if I click that, it's going to add a vertical relation and make that line vertical. What that relation means is that when I click this line and I try and move it around, I can move it side to side, but I can't actually change the angle of the line. If I want to change it back to a line that can be angled and not vertical, I can click on that relation, or I can click on the line and click on the relation here and press delete on the keyboard, and that will remove it. And then I can change the angle once again. In the same way that I could add a vertical relation to that line, I can select two lines and make them, for instance, perpendicular, collinear. Collinear is another relation that we should talk about. Let's make them perpendicular, and that, I don't know where it's put that line. I'm going to take that back. I'm going to move this endpoint here, select them and make perpendicular. Okay, that's going to add a perpendicular relation between those two lines. So with the relations, you can do it to many lines or circles all at the same time. Here I've got 4 circles. I'm going to select them all, and I can make them all equal. So it's going to make them all equal in size. All right, some of the other relations that we can see here with circles. Concentric and co-radial. Concentric means that they are coincident in the center. So if I move one, they're going to move together. Co-radial is a bit hard to show with sketches, but basically it means that 2 circles share the same radius. All right, so here there's actually 2 lines on top of each other. If I press delete, you can still see the remaining line. So why are these relations important? Well, we've touched on it briefly already, but it comes back to your design intent. So if we look at the design intent of the shape that we've created here, there's some other skills that we're going to learn very shortly with sketch tools, with using trim and mirror. But we're going to make this a symmetrical part. But some of our design intent for this part is that this bottom line here is horizontal. This side line here is vertical. This line here, actually we're going to add an angle dimension to that. So we don't want it to be horizontal, because if it was to be horizontal, we can't actually add a dimension to it that changes the angle of that line. So we very specifically do not want a relation on that line. All right. And to get fully defined, which is what we're aiming for, we need to have a combination of dimensions and relations. So I think now's a good time to talk about fully defined. And to do that, I'm going to stay in this file, but I'm just going to start a new sketch and hide the first one. So let's do a new sketch on the front plane. And for this simple exercise, I want you to draw a rectangle. And I want you to draw a rectangle off to the side like this. And now we're going to talk about adding dimensions. So to add dimensions on our sketch toolbar, there's a button here called Smart Dimension. And this creates a dimension for one or more selected 2D or 3D sketch entities. You can drag or delete a dimension while this tool is active. So we select this tool, and then for our first dimension, we're going to click on this bottom line and drag the cursor down, click, and you'll see this dimension entry pop up. Now, what I highly recommend for anyone using SolidWorks is that you have a keyboard with a number pad on the right-hand side. If you don't have one, it's okay. You can use the numbers at the top. But if you are going to be a designer or engineer for your career, it's definitely worthwhile having a number pad here and learning the position of these numbers so you can do it with your eyes closed. I'm going to enter this number and I'm going to make this 50 millimeters. So I'm going to type in 50 and hit enter, and that has added the 50 millimeter dimension to that line. I can also dimension from two lines. So I could dimension the side one here, or I can dimension it by clicking the bottom line and then the top line. And for this dimension, it's going to be 30. Okay, now this rectangle is nearly fully defined or fully constrained. Now I can tell it is underdefined for two reasons. One, I can obviously see some blue lines. And if I click and drag on any of those lines or points, I can move it around. And in the very bottom of my screen, it's a bit small to see, but down here, I can see the words underdefined. The sketch is underdefined. There's another way I can tell, which is in my feature tree, which is the little negative symbol next to the sketch. That means that that sketch is underdefined. And that's a very easy way to go through your files later, once we've started building out some multiple features, to see and to make sure if everything in your file is fully defined, because you can see it in its sketches. There are very few rare examples where sketches will always be underdefined. One of those examples is using text tools. All right, we'll highlight that later in the course. It's not imperative for every single sketch to be fully defined, but any that are using geometry to create your parts, you want that to be fully defined. Let's go back to editing this sketch. Now, why is this still underdefined? The reason is that it's got no reference to our origin. Now, origin being this red dot that we can see on the screen. And to explain that a little bit further, we touched on it earlier in one of the earlier lectures. I'm just going to show the front, top, and right plane, and also the origin in the feature tree here. Well, you can see when I click on the origin, it's highlighting this point here right in the middle. The origin is the 000 point, reference point of your space, of your workspace, of your file. If you ever want to fully define anything, it has to be related some way to the origin. It does not have to be touching the origin specifically, but it needs to be related to it in some way. And what I mean by that, we go normal 2 here. To fully define this rectangle, I can simply drag this corner, move to the origin, and then you see all my lines turn black. And down here, I can see it says fully defined. That is one way of making it fully defined. Okay, it's got a coincident relationship from this corner to the origin. Let's delete that relationship. Now it's on the origin, but it's now underdefined because it does not have that relationship between that corner and the origin. Let's drag it out again. Another way to make it fully defined is I select this line, the origin, and make it coincident. And then I grab a dimension and I go from the origin out to this line here, make that 60. Once again, my sketch is all black and it is fully defined. And that's because I've said that this line must be in line with the origin and that this line is 60 millimeters away from it. So there's always multiple ways of doing the same thing, as we talked about earlier, and we'll touch on many times. It comes back to your design intent. If this sketch, for whatever it is I'm designing, is intended to be 60 millimeters away from, let's say, the right plane or the origin, then this is the way to set it up. But if I want this sketch to be centered and be symmetrical, then I might want to do something like this, where the origin is on the midpoint of this line at the bottom. Okay? Both of them are fully defined, but it comes back to the intent behind what you're trying to achieve. Let's look at a few more dimensions in this sketch by adding a little bit more geometry. There's some things that I want to show you before we move on to finish the part. So to dimension a circle with a dimension tool line, all you do is click the outer edge of the circle, and depending on where you move your cursor, you'll get a diameter in a different sort of view. Okay, to make that 20. Now, if I have an arc rather than a circle, that is going to give me a radius. You can see the diameter symbol here and the radius with an R symbol here. I can also dimension an angle. So this line here, I can dimension from the horizontal to the angle line, and I get this angled dimension tool. Right now, this is 20, but if I move my cursor, down, I'm going to get the obtuse angle between those lines. And over this side, the reflex angle. I think those are right. And this is the acute angle. Again, your dimension here can be driven by your design intent. So I want to, with those shapes, just going to add some relations and explain some of the problems. Now you can dimension from circle to circle like this. It's going to go from center to center. Or you can hold the shift key and click on an edge of a circle and get a dimension between the actual curve. All right. So add some more dimensions in, add some relations in, and get your sketch fully defined. Work out what you need to do it. All right. This is looking pretty close to fully defined, wouldn't you say? But I can see down here, it still says underdefined. And if I accept the sketch, there's still a minus sign here. What I need to do is develop an eye for detail and look for any blue points. So it's not just the lines or arcs or circles, it's also the end points. Now, as much as I want to zoom in here, it's not actually going to get any bigger on the screen. But what I can see here is that while this line is black, this endpoint is blue. And that's because I can drag it. I can make it longer and shorter. So if I want to fully define that line, I have to add a dimension to it to make sure that that endpoint also becomes black. Same thing for this arc over on the left. See this endpoint? I can drag it. Let's drag it around here. And let's drag this one around here. I'm starting to get some errors, which will be interesting. Okay, those endpoints are now constrained, and my sketch says fully defined. And if I press OK, you'll see that little minus sign disappears. Okay, it's gone. That's a fully defined sketch. Right, so with dimensions, just like with the relations, how you can delete them, you can also delete dimensions. So I can delete this 30 dimension by clicking on it and then hitting the delete key. That means this circle is now underdefined. I can move it once again. You can also change dimensions though. So if I want this 50 to be 40, I just double click on that dimension, type in 40, hit enter, and now I'm getting an error. This is good. We will come back to this. I'm going to create a few errors and then we will deal with it. Why didn't that work? There's an error there too. I don't think that one's working properly. All right. You will notice this red line here. You'll notice that this arc actually hasn't changed shape. You'll notice this line hasn't changed shape. And you may have noticed that in the bottom of my screen, I have some warnings starting to pop up. Invalid solution found and item conflicts. Item is unsolvable. Item is unsolvable. Let me delete some dimensions so we can get to a point where it is solvable again. Now, let me explain what just happened with a very simple example. Let's say I have one line that's here, and one relation we haven't talked about is the fixed relation. The fixed relation is like locking something in place. It's really bad because while it can fully define something, it doesn't let you move it around or control it with any dimensions or other relations. So it's kind of like a shortcut, but it's not a good one. But I'm going to use it in this example. So let's say I've got this line that's horizontal and I want to make it 20. And then I'm going to draw another line, and this line is going to be vertical there, and it's going to be 6 millimeters apart. And this line is going to be 25 millimeters long. But now I'm going to select both lines. And I'm going to say I want them to be equal in diameter. I want them to be equal in length. So what we've told SolidWorks to do is to make these lines the same length, and we've given them different dimensions. And you can see now on the bottom of the screen, we get a warning, we get a red warning, and it says the sketch is over-defined. So over-defined means we've gone too far with adding dimensions and relations, and that SolidWorks cannot calculate the answer. Now, as a beginner, and when you're doing your sketches, getting over-defined sketches with warnings and errors is one of the most common things that will happen to you. My advice is this: always deal with the red errors first. Oftentimes, you will have a sketch and you might have many errors, some yellow, some red. Could be more or less one or the other. But the red ones are the critical ones. And if you solve those first or delete or remove them, often all of the yellow dimensions or yellow relations or yellow errors will be able to resolve. So the best way of solving it is to understand what's going on. Now, that can be difficult in complicated sketches with lots of relations and angles going on. So sometimes the best thing is to just pull it back, start again with building up the relationships. So building up the relations and dimensions. And to do that, you simply select what's red. Now I'm not selecting the line, I'm just selecting the relation. And I'm going to hit delete on my keyboard. And once I've deleted that, the sketch is no longer over-defined because these two are able to solve. All right. Now, those lines no longer need to be equal, which means the dimensions can be calculated, the lines can be made to those lengths, and it works. We'll see more errors as we go. It is definitely a troubleshooting type scenario, but it's one that you get better with practice. So what was happening before over here is I'd made the distance between the centers smaller, but the distance between these two arcs remained the same and it couldn't calculate. So that's what the problem was. Awesome job getting through part 3. This is where sketching starts to feel powerful. If this helped you, give it a thumbs up and share with someone learning SolidWorks. In part 4, we'll pull it all together with more real-world tools and examples. Catch you there.